For today's lesson, we're going to create and interpret scatterplots. So a scatterplot is a graph in which we have points that are plotted, and it's going to show a possible relationship between data. So correlation is going to describe the relationship between these two data points. For example 1, we are going to make a scatterplot with the data that's been given. We need to put a title on the graph, so we might put game versus score at the top. You get to make your title. My independent variable is going to be game. We'll label that on the bottom, and score is going to be dependent on which game we're looking at. So for game 1, notice 1, 2, 3, 4 for the number of games, but the number of points are going up to 46. So perhaps we're going to count by 5. So we'll have 5, 10, 15, 20, 25, 30, 35, 40, and that should do it. Now we're ready to plot our points. First point, we have 1 game, 6 points. 2 games, 21 points. 3 games, and that would be 46 points. We'll have 4 games with 34 points. Now make certain the points are easy to see. So you're looking for a trend. What is happening with these lines? So can you figure out if the lines are heading upward or downward? What are these lines doing? So let's see here. When I'm thinking about my lines, would I draw a line that goes here to represent the data? Now, I'm hoping you say, no, that's not a good line. What if I were to move that line a little bit further up? If I were to draw the line through the data, so some of the points are below, some of the points are above. So because I can draw a line that tells us what the relationship with the data is, that means there is a correlation. Since the line is increasing, that is a positive correlation. So if you have a positive correlation, you can draw a line with a positive slope. If you have a negative correlation, you can draw a line with a negative slope. If there's no correlation at all, the dots are scattered everywhere, you cannot draw a line to represent your slope. So for number 1, I want you to plot your points. Notice again, the values on your cookie axis are going to go from 7 through 24. So maybe you want to count by 5s again. So I've got 5, 10, 15, 20, 24. The independent variable is the time baked, and maybe you're going to call this cookies in the jar. So plot your points now and see if you have a positive or a negative correlation. Did you notice that your line is going down? Is there a correlation for the data? The answer is yes. And since the line is heading downward, it is a negative correlation. So draw that line and make certain that you understand why it's negative. Let's look at example 2. The graph shows your daily temperature and a number of people that go to the beach. Is there a correlation for the data? So as we take a look at this data, do you notice if I draw a line downward, that does not look like my data. If I draw a line here, I don't have data points above or below, so that doesn't look right. I'm going to draw my trend line so that some of the values are above my line and some of the values are below this line. So is there a correlation? Yes, there's definitely a correlation. Describe this correlation. The correlation is positive and traveling through the data. So when you think about a runner's time and the distance to the finish line, would you think that there is a correlation? Let's think about that. If you have a finish line and the amount of time that a runner is running, as time goes on, the distance that you're going to go to is getting smaller. The distance to the finish line is getting smaller. So yes, there is a correlation, but be very careful. This correlation is negative because the distance is getting smaller. So we have a negative correlation. Question C. Is there a correlation between the temperature in Houston and the number of cars sold in Boston? Think about that. Is there a relationship between the temperature in Houston and the number of cars sold in Boston? So trend line or line of best fit helps to show this correlation between the data more clearly. I'm looking at the age of a car. Now, one of these scatter plots is right, and the other two don't make a whole lot of sense. For example, this car is -4 years old. That does not make sense. Over here, year 1, the car repairs are costing about $300. And then in year 6, the car repairs are costing about $900. So it does seem that as you own your car, the cost of the repairs should go up. Now, in this next one, it says that the age of the car is 0 and it's costing you $1,000 to repair it. And then 6 years later, it costs you $200 to repair it. I'm thinking that a negative correlation does not make sense for this type of problem. Let's use this graph where the cost goes up as long as you own your car. So follow the directions on this following page. Once you've completed some of the problems, we will discuss them. For number 5, you are to draw your trend line. So when you draw your trend line, hopefully you drew it through your points. Some of them are positive, some of them are above, and some of them are below. Now, the question is, how many rolls of wrapping paper need to be sold to raise the $500? So the money raised is your dependent variable. As we look at it, the number of wrapping papers that need to be sold looks like it should be around 75 according to my trend line. As you tried question number 7, think about what's happening. You're growing a plant. The seeds in graph A are giving you a plant that's 70 inches tall. Graph B gives you negative time, but graph C looks pretty good. Complete this last page. Notice for number 12, the correlation of a person's shoe size and length of their hair really doesn't make sense. When you work on number 16, put labels on the x-axis and y-axis, and don't forget to put a list on top. Maybe you put the title dinner at the top and then follow the directions.